You are welcome to Solo for Math. This is Solomon, and this is an extension of our series of trigonometry. Today we are covering, or in this video, we are going to cover solutions or how we solve trigonometrical equations. Yes, we're going to cover 10 examples. So watch till the end. First example, if you're given sine theta equals to 0 and they want us to solve that equation, it means they want us to find the values of theta. One thing we note with trigonometrical equations, they have infinite solutions. Most of the equations we've looked at before in algebra, they have finite solutions. One solution, two solutions. For example, quadratic equations have two solutions. For trigonometrical equations, they have very many. We cannot list all of them, but we're going to see how we can list in a given range. We shall always be provided a range in which the values of theta should be given. Otherwise, if the range is not given, then we are only able to list a few. Because there are very many, we cannot exhaust them. All right, our first example is sine theta equals to 0. So to get theta here, we always get the inverse of the number that is on the other side of the equation. For example, if this is sine theta, we want to get theta. The only way we can get theta is by getting the sine inverse. We get the inverse of the ratio given. So since we are given sine here, so theta will be sine inverse of the number on the right hand side is 0. And go and press on your calculator. What is sine inverse of 0? If you press on your calculator sine inverse of 0, it will give you a 0. To give us a 0. So the first answer we get is actually our first angle, but doesn't mean that this is the only value of theta that satisfies this equation, because there are very many values of theta that when we put here, they give us a 0, as we are going to see. So how do we get the other values? For sine, we are going to use our quadrants, if you remember very well. If you don't remember, kindly go back and check on the previous videos and understand this. Where do we have 0 in this quadrant? We need to find out where 0 is. Then also we come back to this equation given. We're given sine theta as 0. Is 0 positive or negative? We need to identify in which quadrant is this angle. So since 0 is neither positive or negative, we expect it to be, and the angle, when we found theta, we got it as 0, so 0 we expect it to be along this, the horizontal. It's along the horizontal. So if it is sine and you get theta as 0, the first angle as 0, then you should expect the other angle to be 180. You should know that. We looked at the graphs of sine, cos, and tan. We saw that at 180, when theta is 180, sine is 0. As when it is when theta is 0, we also see as we saw sine 0 as 0. So what happens? These are the first two values. We shall always get the first two values. We are going to look at other examples so that this becomes clear. Otherwise, whenever we get the theta, it will always be an acute angle. It means it is an angle that is less than 90. If it is always less than or equal to 90, then the other angle will always be gotten by 180 minus the first angle you've gotten. So for example, here we got our first angle as 0. So the next angle expected to be 180 minus theta. That is if the theta is positive and we had a ratio here as, especially for sine, if sine was positive, then the first angle is 0, then the next angle we can get it by 180 minus theta. Now, since our first angle was 0, we got 180 minus 0. That's why we are having our other angle as 180. Now, there are very many others. How do we get those other angles? Those are other angles, we can get them from this formula. Theta plus 2 pi n. 2 pi n, 2 pi is the same as 360. So why are we putting here 2 pi? Because sine and actual cos have a period of 360. Like after 360, the graph behaves the same way. You can check those graphs. If you remember, we had our graph of sine. It was 0 at 0, and at 90 it was at 1. At 180 it was at 0. At 270 it was at -1, and then back at 360, which is 0. If you remember, we drew our graph as this smooth curve, or something like that. So you see, after complete revolution, after 360, we expect the graph to behave the same way. Okay, so we see that there is another point on that graph where sine will be again a 1, where it will again be a 0, where it will be a -1, where it will be again a 1, like that. So since there's a period of 360, after getting these two values, to get other values, what we do, we add on these first two values, we add 360. So from 0, if theta is 0, we can get many other values of theta. Okay, we add 360. What do we get? 360. On 360 again, we had 360, we get 720 degrees, and so on and so forth. Now, for example, this question, they didn't specify, they didn't give us a limit, or we don't have a limit of the values of theta. So we could get even a million values of theta. Now for theta, we have theta as 180, we can still get other values of theta as we add 360. So 180 plus 360, we get 540 degrees. On 540, we add on 360, we get 900 degrees. This shows us that at all these values, we've got another values. Sine theta will be a 0. We first got these two values, and then from these two values we get others by considering the period. We go on adding the period, 360, 360, 360 on each, and then we answer accordingly. So since we don't have any limits here, I can take my theta's values to be, let me arrange them from the smallest, 0, 180 degrees. We have what next? We have 360 degrees. We have 540 degrees. We have 720 degrees. We have 900 degrees. Now, what about the negative values? Is theta only positive? No. Since they didn't specify, we can also think of negative values of theta. Okay? because there are values of theta that are negative that still give us our sine theta as a 0. So how do we get those values? You see, in this case, we added. In this case, we added 360 to get the positive values. If you want to get the negative values, subtract. From, for example, 0, for theta 0, we can subtract. When we subtract 360, we get negative 360, and so on and so forth. You just continue subtracting and continue like that. Then when theta is 180, do the same. Get 180 minus 360, and you get negative 180. And you get, when you subtract, we shall get negative 540 degrees, and so on and so forth. Actually, for these, you realize that for every positive, there is a negative value. For every positive, there is a negative value. So these are all values of theta that give us sine theta 0. You can check some of them. For example, sine, just tap sine and put in a negative value, negative 540. It will give you a 0. And if they don't give you a limit, though we shall always give a limit, that is what we do. If you're given a limit, we choose values of theta in the given range. All right, let's look at number 2. We have cos theta equals to a half. The same steps we go through. Find theta. We say the first step is to find the first value of theta, an acute angle that gives us our cos theta as a half. So that acute angle is got by the inverse of the ratio given. So we have cos here. So theta will be given as the cos inverse of this fraction here. What is cos inverse of a half? This one you can even know. We looked at how to find the ratios of 60, 30, and 45. You should know that this is already a 60. That cos 60 is a half. Now this is one of the values. So we said for cos and sine, you expect the first values to be, we expect 2 values. The other value of theta is, we can find it from applying or using this quadrant. For example, we are having here cos theta as a half. If it is a half, it is a positive value. So we find out where is cos expected to be positive. This is, here we have all of them positive, here we have sine positive, here we have tan positive, and here cos positive. So we expect cos to be positive in the first quadrant and then the fourth quadrant. So measure that angle 60, our angle 60 degrees. Measure it, so it could either be here or here. We measure it from the horizontal. Now, it means our theta is either in the first quadrant or in the fourth quadrant. But we've already seen that one angle that gives us cos theta as a half is 60. Now, which angle gives us cos theta as a half in this fourth quadrant? That angle should be bigger than, actually it is bigger than 270 because we have 270 here. How do you find that angle? This is what we do. Just measure that angle from the 0 mark up to where we find this line here. Okay, so which angle is this? We expect it to be 360 minus 60, and that gives us a 300 degrees. So it means our other value. The theta in the fourth quadrant that gives us our cos as a half is 300. So we can now find other values of theta. Now for cos, to get this second value, if cos is positive, then the other value can be gotten from 360 minus the first value that you got. Yes, we can use this generally if you don't remember this, but this is very important to remember and to know how it comes about. But you realize that if cos is positive, then after getting one value, this acute angle, then the other value, the second value that gives us cos as a half is 360 minus theta. Now we find other values of theta that gives us this as a half. Since we don't have a range here, we can find both positive and negative values. So let's start with the positive values. For theta equals to 60 degrees, we say cos and sine have a period of 360. So we go on adding 360 on each of those angles, the initial angles. So 60, we add on 360, what do we get? Get 420. When we add on that very one, we add 360, we get 780, and so on and so forth. Then we have a 300. And for 300, when theta is 300 degrees, add 360, we get 660 degrees. Add 360, what do we get? We get 1020 degrees, and so on and so forth. Okay, and then the negatives, we can get the negatives. If theta is 0, we said what we do, if theta is 60, what we do to get the negative values, we get that 60 and subtract off 360. Because the period is 360, now we are moving backwards in the negative sense. So we mean we have negative 300, okay, as one negative. Then on that we subtract 360, you will get a negative 660, and the next one will be negative 1020 degrees, and many more others. Okay, and then for this, the same. If you want to get the negatives for this, we subtract 300 minus 360, we get negative 60 degrees. Subtract from this, from negative 60, we subtract 360, we end up with negative 420. When we subtract again 360, we shall end up with negative 780 degrees. Actually, for this, you'll find that our values of theta, you see, are both positive and negative 60 degrees. We had positive and negative 300 degrees. We had positive and negative 420 degrees. We have positive and negative 660 degrees. We have positive and negative 780 degrees. We have positive and negative 1020 degrees. This is what we get for this question. So those are the values of theta, and all these give us our cos theta as a half. And there are actually very many others that we cannot exhaust, as I've already told you. All right, let's look at number 3. We have cos 2 theta as 0.6428. Now we're having our angle as 2 theta. So we want to get the values of theta that give us cos 2 theta, cos as 0.6428. So what we do, the procedure is the same. We find 2 theta, which is equal to the cos inverse. Here today they give us 2 theta. We have 2 theta, non theta. So our angle we are finding is 2 theta. So 2 theta will be cos inverse of 0.6428. Tap on your calculator. What do you get? If you check this, it gives us, in the calculator it is 49.9999. I'm going to approximate it to 50 degrees. So this is 2 theta, but our question wants theta. We want to find the value of theta. So it means we are going to find values of 2 theta and then divide them by 2 to give us the theta. To make sure we don't miss out any value, let's find out the limit of the 2 thetas that we are finding. If the thetas are ranging from -8 to -180 to 180, then the 2 thetas, they should double this. So this will be -360 degrees, and this will be +360 degrees. So we find values of t theta between -360 and then 360. So we have the positive value as 50. Let's find the next value, the other second value. This is an acute angle. Okay, let's find out. We said we expect 2 values. The first 2 values, the values of sine and cos are ever in pairs. So our cos 2 theta was a positive. We expect cos to be positive in this quadrant and this quadrant here. So if we have our 50 here, we measure that angle from the horizontal line. This is our 50. So we already have the acute angle that gives us our cos as this, as a 50. We want to find an angle that puts our cos in the 4th quadrant. That angle we say should be greater than 270 and maybe less than 360. So how do we get that angle? I already told you for cos, if it is cos positive, like here we have, this is a positive cos, our other angle is 360 minus the first angle, which was 50. So this gives us 310. So we expect the other angle to be 310 degrees. Now, if it is 310 degrees, let's find the other values. So the other values, because the period is 360, we said go on adding 360. So when theta is 50, let's find the series of values here. We said go on adding 360. Oh, this was 2 theta, non theta. We are still looking for 2 theta. So for 50, we add on 360, we get another value in the series of 50 to be 410 plus 360. The other value will be 770. But we see all these values are already bigger than what we expect the maximum to be. So it means we are not going to even use them. Okay, now let's find the negative values for this. The negative values for 2 theta, we have, we said get 50, subtract of 360, you end up with -310 degrees. Continue subtracting off 360, we get -670. This one is disqualified because it is already beyond the 360 that we want, negative. So let's check when 2 theta is equal to 310. The series of values here, the positive values, we expect this When we add 360, this will be 670 degrees, already bigger than what is needed, so we shall not need this. We can stop there. And then the negatives, we said subtract 310 minus 360, we end up with a negative 50. Subtract from negative 50, subtract 360, we get a negative 410 degrees. I'm sure when we subtract, we're going to get a value that is bigger than negative. This one is already bigger than negative 360. So we don't need to continue from here. So it means our 2 theta values are, let's choose values that are in this range. In their order, we have negative 300, this one 310 degrees, followed by negative 50, followed by a 50, followed by a 310 degrees. So our theta will be, we just divide each of these. So when we divide this by 2, we get negative 155 degrees. When we divide this by 2, we get negative 25 degrees. When we divide this by 2, we get 25 degrees. When we divide this by 2, we get positive 155 degrees. And these are the values of theta that give us our cos 2 theta as this. Number 4, we have 2 sine squared theta equals to sine theta. How do you go about this? I will put the sine theta on the left hand side. So I will have 2 sine squared theta minus sine theta equals to 0. I'll tell you later on why it is not right to divide. Someone should be wondering, why didn't you divide? For example, if we had this and then we say divide by sine, because it's a common factor, divide by sine on both sides. Okay? Someone will quickly do this so that they reduce the expression. That's wrong. If we do this, we are ignoring, or we are eliminating, we are giving up on other values of theta. So this is the right step. So here we factorize out sine theta, and this gives us 2 sine theta minus 1, which is equal to 0. So we know that for this expression to be equal to 0, this is multiplication. We are multiplying this and this. So either one of these should be equal to 0. So either sine theta equals to 0 or 2 sine theta minus 1 equals to 0. All right. So we're going to solve these. So like for example, if sine theta, for sine theta equals to 0, get theta by getting the sine inverse. We already did this, sine inverse of 0, and we saw that it gives us a 0. I'll ask you and go to the first equation, for the first equation that we did, and you find the values that follow after here were 0, 360, we had 720, and so on. But since our values of theta are ranging from 0 and 360, it means this is out of range. Then we go to the next equation. If our 2 sine theta minus 1 is the one that is equal to 0, it means my 2 sine theta would be equal to, take the one on the other side, we have this. So it means we have sine theta as 1 over 2. We've already seen something like this also. Let's go through it. If we have this, it means our theta is equal to sine inverse of 1 over 2. What is sine inverse of 1 over 2? We should know this as a 30. If it is 30, we say there are values. There's another value of theta, the second value. If this is the acute angle, and we're having this as a positive, sine was positive here, sine theta was a half positive, we expect it to be in either in the first or the second quadrant. So if this is 30 and this is 30, the angle that puts this sine in the second quadrant should be bigger than 90 and less than 180. And I already told you, if sine is positive, then that angle will always be 180 minus the original angle, the first angle that you got. It is this one. We measure it from here up to here. So that is 180 minus 30. We remain with this as 150 degrees. So the next angle is 150 degrees. So exhaust other values. So under 30, we add 360. We get 390, which is already beyond the 360. Even here, when we add 360, it will be beyond the 360, which is needed. So now we conclude that our theta will be equal to, let's choose the values that are in this range. We had a 0 here, followed by, we have a 30 here. 30 was followed by the 150 degrees. Oh, we forgot a 180 here. There was a 180 here. Yes, 180. You can refer to the first video. 180 was here, and then 360. So these are the values of theta in this range that give us that balance this equation here. Okay, number 5, we have tan theta equals to 2 sine theta. The best step here would be converting this we want to create a solvable equation. So the best thing I will do is to convert this tan. The best thing I will do is to convert this tan into sine and cos, which is equal to 2 sine theta. And if I cross multiply here, we shall have sine theta equals to 2 sine theta cos theta. When we bring this on the left hand side, we have sine theta minus 2 sine theta cos theta, and this equals to 0. When you factorize out, we have a common factor, which is sine theta. Factorize out, we remain with 1 minus 2 cos theta equals to 0. So either sine theta equals to 0 or 1 minus 2 cos theta equals to 0. Now we use these two. Each of these will give us solutions or values of theta. The same way we said we cannot cross out these, because when we eliminate them, we are ignoring some values of theta. So, like we looked at this equation here. When sine theta was equal to 0, I want you to go on and solve and go through it the same way we did the first expression, but the values of theta there were, this is when sine theta is equal to 0. Theta, we got the values that are in this range are 0, we had 180, we had 360. Yeah, the rest were bigger than this. And then when you look at 1 minus 2 cos theta, this is equal to 0. When we simplify, when we take this on the right hand side, to give us 2 cos theta. If you divide by 2, we end up with cos theta, which is equal to a half. And we looked at this as the second example. And we got the values of theta there as we had 60, we had 300, these are degrees, we had 420, and so on. You can check. So in our range here, what are the values that are needed? We need values from 0 up to 360. So it means our theta is equal to, we combine them from the smallest. So the smallest is 0, followed by 60, followed by 180, followed by 300, and then 360, because it is inclusive. These are degrees. All right, number 6, we have tan theta equals to 1. The same procedures, find theta by getting the inverse of tan inverse of 1. And when you press on your calculator, we already looked at this as a 45. Because we looked at tan 45 as a 1. So the tan inverse of 1 is 45. So here we want values of theta between 180 and 360. So what are the other values of theta? What is special with tan? For cos and sine, we said they are pairs of values. For tan, it's only one value. The reason is its period is 180. Like it repeats, the graph repeats, the values repeat after every 180. So let's find out. Where do we have tan as positive? We have tan as positive in either the first quadrant or the third quadrant. So if this is 45 and this is 45, you see that the acute angles that gives us tan theta as 1 is 45. We already have it here. So the other angle that puts our tan in the third quadrant, that angle should be bigger than 180. You see that is 180. We find it from here up to this boundary line here. So the angle here moved is, we have moved 180, then we add on 45. So this gives us a 225 degrees. So it means our other angle is 225 degrees. All right, so what do we do here? For sine and cos, we're adding on 360. Like after every period, the period is 360. For tan, the period is 180. So it means we add on these 180. So when we add on 45, 180, it will give us this. Okay. So when we add here 180, what do we get? We get 405, which is actually bigger than what we expect. If we go on adding, the values we shall add will be bigger. They will be bigger than the range. So it means our theta here expected is actually only 225 degrees. Number 7. Sine theta equals to negative 0.7660. We go on the same procedure, find theta as the sine inverse of 0.7660. What we are going to do here, if we have the sine or tan or cos as a negative, we should first ignore. We may first ignore the negative, and then we find the angle, the acute angle that gives us our sine theta as a positive. Okay, the angles will always be the same in either case. The angle will be the same. The only difference is one will be measured clockwise, the other one anti-clockwise. So that's why we first ignore the theta at the negative so that we find the angle. So when we check on our calculator, this will be approximately 50 degrees. Okay, so if it is 50 degrees, this is an angle measured in the clockwise direction to give us the sign as a negative. Or we can come back to our quadrant here. Our 50, we've got our angle, we've got it as 50, but our sign was negative. So in these quadrants where is sign negative, we expect it to be negative in the third and the fourth. So if we measure angles 50 and 50 from the horizontal, so how do we get the other values of the values of theta that give us sign as a negative? Because this one, if we put 50 to give us a negative, to give us a positive. So since they want positive values, what we do, we come from the zero mark, move anti-clockwise until when you find any of these lines that made 50, the one we marked under the horizontal line. So which angle have we moved to reach this angle? You realize that we've moved an angle of 180 plus 50. So this one gives us 180 plus 50. It gives us 230 degrees. So it means one of the angles, theta, that gives us our sine theta as a negative, this is 230. The other one is we still continue rotating until when you find this other line. So which angle have we moved? You realize that angle is, the easiest way to get it is 360 minus 50, which is equal to 310. So we can find other values. These are the first values of theta. So for sine theta equals to negative 0.7660, our theta is expected to be, we have gotten a 230 degrees and then a 310. These are the first two values. So how do we get other values? By adding 360 on each of these. But when we add, we see we are going to go beyond the 360 in our limit. And if we wanted to get values that are negative, we would move anti-clockwise. So the first one would be, of course, negative 50. The next one would be, which angle have we moved up here? It will be negative 130, and so on and so forth. So we can repeat the revolution until when we come back here and we calculate that angle. Continue until when we reach here and we calculate that angle like that. But since our range is between 0 and 360, it means these are the only possible values of theta. If you wanted negative values, still we would use a calculator. We would subtract from these. You subtract 230 minus 360, it will give you negative 130. Then you get a 330 minus 360, you will get a negative 50, which we already gotten by moving, by using these quadrants here. All right. So we use the 50 to help us get the angle, the acute angle that would give us our sine, our ratio sine theta as a 0.7660. We were interested in the positive values, that's why we moved anti-clockwise until when we found these lines here. So let's look at number 8, where we have cos 3 theta equals 2 square root of 3 over 2. Here we first find 3 theta the usual way, which is the inverse of cos of root 3 over 2. Okay, this one we can also get it from our heads, because we know that cos of 30 is a root 3 over 2, so it means the cos inverse of root 3 over 2 is 30 degrees, or you can place on your calculator and you get the answer. So we said cos and sine will always give us two values. Two values are expected. So for cos, we said the other value will always be 360 minus the first value gotten, which is 30, and this will give us 330. I already explained this, because when cos is positive, this is true for cos positive, we expect it to be either in the first quadrant or the third quadrant. So the angle is here 30. The angle here is 30. So the first acute angle that gives us our cos as 30, our cos as this is 30, we have it. So the other one is this bigger angle, the angle bigger than 270 and less than 360. That's why we get it by subtracting here. So this will be, the next angle is 330. Now we can get ranges of values, more values here. By what? By adding 360, because we say the cos repeats itself after 360. So let's first examine so that we don't miss out on any value. If our theta is supposed to be between 0 and 360, what about 3 theta? So we expect it to be, multiply this by 3, between 0 and 1080. So let's exhaust the thetas, the 3 thetas. We have 30 and then 330. So when we add 330 here, 360 here, we get 390. When we add on this, we get 690. When we continue, add 360 on this, we end up with 750. We are still in range. When we add on this, what do we get? We get 1050 degrees. Okay, I think you can see that when we continue and add, this may go beyond the 360. The 1080 for the 3 theta. It's the 3 theta. So if you want theta, then we're going to divide through all these by 3. So we shall get a 10 degrees. This one give us a 10 degrees. This will give us 130 degrees. This will give us a 230 degrees. Our range is between 0 and 360. So we are still on the right track. This will give us 250. and then this will give us 350. These are the values of theta in this case. Number 9. If we have tan squared theta plus tan theta as 0, the easiest step is, of course, as you can see, is factorizing out a common factor. Tan theta out, we remain with tan theta here plus a 1. This equals to 0. So for this to be equal to 0, either tan theta equals to 0 or tan theta plus 1 equals to 0. So if tan theta equals to 0, let's find the values of theta here that we expect. Theta will be equal to tan inverse of 0. When do we have tan as 0? The first circuit angle that we expect is a 0. So our first angle is 0. Okay, let's try to examine using the quadrants. If this is our 0, along this line, where do we expect tan to be positive? Tan should be positive here, and then somewhere here. So like the boundary line, because we've gotten our tan theta is 0, it is neither positive or negative. So we expect it to be along the line in the middle there. Okay, so along this line here. So we've found our angle as 0. Okay, so the other angle would be 180, because even say the period for tan is 180. It repeats after 180. So if it was first 0 at 0, it means it will appear again as 0 at 180 degrees. So we can add on and so on and so forth. So we would add on here another 180 to give us 360 degrees and so on. But our limit doesn't take us to this, so this one is out. Now we have negative values here. Okay, negative values. So what do? We subtract. To get the negative values, we subtract. So it is still equal to, get 0 minus 180. We're subtracting the period, which is 180. And then here, when you subtract 180, sorry, on this, when you go on and subtract 180 to give us negative 360. But this one is out of range. So it means our values are there. But we still have this, so we shall not conclude before. If tan theta plus 1 equals to 0, let's find the values of theta here. When we simplify, this will be tan theta equals to -1. So we can first ignore the negative and we look for theta when the tan theta is 1. So what is the tan inverse of 1? This one gives us 45 degrees. So our angle is 45, but remember our tan theta was a negative. So where do we expect tan to be negative? We expect tan to be negative either in the second or the fourth quadrant. So if this is 45, we measure these angles from the horizontal. 45. Okay, so the first values, the positive values, we can get them by moving anti-clockwise. So the first positive value that puts our tan in this quadrant is this angle here, which is 180. So for tan theta equals to -1, our theta, the first theta would be 180 minus 45, which is a 135 degrees. Another one would be moving from here up to here. Or we simply add 180 on this, but that would be bigger than what we expect. So let's exhaust the negative values. The negative values would be, we move clockwise. The first one is negative 45. Negative 45. And then the other one is move clockwise until when we meet this line. So it is 180 plus 45. 180 plus 45, which gives us negative 225 degrees. We saw already this is even bigger than the minimum that we want. So we conclude that our theta is equal to the smallest value. The smallest value was negative 180 from here, followed by the negative 45, followed by a 0, followed by 135 from here, and then finally 180 from here. These are the values of theta that satisfy this equation. And lastly, we have cot theta equals to 5 cos theta. For theta, values of theta between negative 360 and 360. So the next step here is to convert this cot into cos theta over sin theta. And this is equal to 5 cos theta. If we simplify, cross multiply, we shall have cos theta equals to 5 cos theta sin theta. And if we take this on the left hand side, we have cos theta minus 5 cos theta sin theta equaling to 0. There is a common factor, which is cos theta. When we factor it out, we remain with 1 minus 5 sin theta. This is equal to 0. So either cos theta is equal to 0 or 1 minus 5 sin theta equals to 0. So these two equations will give us the solutions. So let's look at the first one from let's look at if cos theta is a 0. This one we already did it, and we found out the values of theta. You check in the previous examples we've done. We had our value of the first one as 90, the second one as 270 degrees. Since we're expecting negative values, we said get these and subtract off 360. So when you get negative 90 and subtract off 360, you will get, and subtract off 360, you get negative 270. When you get this and subtract off 360, you get negative 90. So we have plus or minus. Okay. Let's get other values from the second equation, which is 1 minus 5 sin theta equals to 0. We have 1 equals to 5 sine theta. If you divide by 5, we end up with our sine theta as 1/5. Get theta from the sine inverse of 1/5. What do we get? We get 11.5 approximately on your calculators. So we said if sine is positive, like here it is positive, then the other value is 180 minus the first value, and this gives us 168.5. If you use a calculator and subtract, we get this, or we can even use the quadrant as explained before. Alright, so from this we can get the negative values. We said to get negative values, subtract 360. For cos and sine, we subtract 360. When we subtract 360 from this, we get negative 348.5. And when we subtract on this, of course, for the first one, if we continue subtracting, it will go beyond the expected limit. So we just leave it here. You can try and see. If we get this and we subtract off 360 to give us negative 700 and so on, it is bigger than the limit. So we go to this 168.5 minus 360. We get negative 191.5 degrees. And when we continue to subtract, it will be bigger than the expected limit. So the values of theta now would be negative 348.5 degrees, followed by negative 270 degrees from here, followed by negative 191.5 degrees from here, followed by negative 90 from here, and followed by, now the positives, we have 1.5 degrees, followed by the 90 degrees, followed by the 168.5 degrees, and lastly 270 degrees. Wow, thank you for watching. We can try out more and more other examples of these. If you've liked these videos, if you've learned something, support by subscribing, share, comment, and like. Goodbye.